All right, welcome everybody. Thank you for joining our GitLab CI new customer orientation webinar. My name is Patrick Harlan, and I haven't had a haircut since February. I'm a manager of technical account managers located out of Portland, Oregon, and I've been with GitLab a little over 2 years. Our webinar today is intended to be an overview and an orientation of GitLab CI. We'll be talking about the architecture, how GitLab CI works, and some of the key concepts that you'll need to know to get started with GitLab CI. This is really intended for an audience of customers, existing GitLab customers who are kind of new to GitLab CI, or anybody who just wants a refresher. Maybe they are using GitLab CI today, but they want to go back over the fundamentals and make sure that they understand some of the different options you have for getting started. Our webinar today is being recorded. We'll share the recording and the slide deck after the event. Thanks everybody for taking time out of your schedule today. We understand everybody's schedule has been a little weird and disrupted in many different ways. So thank you for taking time to join us. And we hope this helps everyone get up to speed quicker with GitLab CI and be more productive in your day-to-day work. As a result of not using our standard GitLab webinar toolkit, we won't be able to take live questions today, but we will have a slide at the end where we'll have contact information and notes on how to ask follow-up questions after the event. Generally, we'll be directing you to contact your technical account manager. Those are folks in the customer success organization here at GitLab who are responsible for helping customers with enablement and training and making sure that you are able to accomplish what you want to with GitLab. And we'll direct you to them. And if you don't know who your technical account manager is, you can always reach out to me. So we'll get right into it here. And get into our webinar. So by way of introductions, we'll have 4 presenters today. They'll be covering GitLab CI/CD, an overview and kind of an architecture overview and how it all works together. We'll be talking about GitLab runners and executor types, walking you through the different options for running your jobs on different types of environments. We'll go through kind of the anatomy of a CI job, what's going on under the hood when your job's executing, so you know how we process your instructions. And then we'll go through an overview of the GitLab CI YAML configuration language, just giving you an overview of the capabilities, what are your different options for controlling the flow within your jobs, and essentially doing everything from build to test to deployment all in one pipeline. So we'll get into introductions to the team. So we've got Martin Bromer, who's a technical account manager located in Leipzig, Germany. I hope I pronounced that correct. We've got Stefan Heininger, who's a technical account manager from just outside of San Antonio, Texas. Brett Gadbury over here on the West Coast out of Los Angeles, and Chester Wachuku out of New Jersey. And they'll be presenting each on a different area of this webinar. So without further ado, we'll hand it over to Martin to start the presentation.
So didn't find the unmute. Hi, I'm Martin, Technical Account Manager at GitLab, and I'm going to give you an overview, high-level overview of GitLab CI/CD. So for the start, what is CI/CD? What does it mean? So there is first continuous integration, or CI, and that is a development practice to continuously integrate, commit code into a repository, and each commit is verified by automated building and testing. So that allows us to detect errors very quickly, locate them easily and early in the development process. And then there is CD, that can mean continuous delivery or continuous deployment, where continuous delivery stands for making sure your code base is always production ready, but the deployment itself usually is a manual step or a business decision, if you will. So that can mean that the deployment to test and staging environments is automated, but usually the deployment to production is still a manual step. Finally, there is continuous deployment, and that means we push every good build to the user. You could also call it continuous release as well. GitLab CI CD can do all of these things depending on the configuration. The benefits of using GitLab CI are first, builds and tests are versioned. So everything is controlled by a GitLab CI YAML file that contains your tests and build scripts, and it ensures that every branch gets the builds and tests it needs. Build artifacts and test results, so all the binaries you build, other build artifacts, and the tests themselves, everything can be stored and explored in GitLab directly. You have Docker support, so we support custom Docker images. Services can be spun up as part of testing, like databases. You can build new Docker images and even run them on Kubernetes. Furthermore, they are multi-language. So the build scripts are command line driven, and that means you can work with any programming language that you like, that you're using. There is real-time logging. So in the merge request, the link can always take you directly to the current log of the builds. And everything is in one application. So there is no integrations to maintain. There is no extra license costs. There's no switching back and forth between applications for the developers, keeping everything nice and efficient. The components of a GitLab CI/CD pipeline are first the jobs. So that are basically the scripts that perform the tasks. For example, npm test, mvn install. So then there are stages. So stages are collections of jobs, and inside these stages there will be run parallel. For example, it could be a build stage, a test stage, or a deploy stage. Then there's pipeline. So that is a set of jobs, optionally with the stages. There are environments. So that means where to deploy. So it can be a test environment, a review environment, or even a production environment. And finally, there is the GitLab runner. So the GitLab runner is a separate application that executes the CI jobs that you can deploy anywhere. And Stefan will tell us more about the runner later in the webinar. As the high-level architecture, what does it look like? So we're starting with the code in the Git repository, and that includes the GitLab CI YAML files that defines the pipeline configuration. Now, if you commit new code to the repository, what happens is that automatically GitLab CI pipeline is started that does the building of the application, and that also executes all tests that you have defined, unit tests, integration tests. The artifacts that are created as a result of the build are then also stored in GitLab. We are calling that a package, and can then be, as a CD part of the pipeline, be deployed to a review environment, staging environment, production environment. What does it look like in GitLab? So GitLab shows you these nice pipeline graphs, and these pipeline graphs show you how all the jobs you've defined are executed in the stages. So here we have a build stage, a test stage, a staging stage, and canary and production. These stages are run in serial to each other. So each stage one after the other. Inside inside these stages, the jobs are executed in parallel. So for example, here, after the build stage was successfully executed, these test jobs would run in parallel to each other. If one job in a stage fails, the next stage is not executed by default unless you specify otherwise. We can also see that these jobs have executed successfully with a green check mark here. We could rerun them for whatever reason, clicking these retry arrows. And we also have two manual jobs defined here. So the deployment to a canary environment in this case would be a manual job that would be executed when you press this play button. Everything is controlled by this GitLab CI YAML file, as mentioned, and that is configuration as code. So that is a YAML file that resides inside the root of the repository by default, and is version controlled along with the rest of your code. And that contains all the definitions for the jobs, the stages, and the environments. It has a very rich and very powerful syntax, which you'll also learn more about in this webinar. So that, for example, controls the Docker image use, what services are spun up, the variables that are put in, scripts that are executed before and after the stages. You can define caching, you can define artifact locations. And there is also rules, complex rules that you can define to control the flow of your jobs. So that's it for the overview. And I'm giving over to Stefan, who's talking about GitLab runner and executor types.
Thank you so much, Martin. So I will share my screen. All right. So I am Stefan Heininger. I'm a technical account manager here at GitLab within the commercial segment. So today I'll be talking about runners and executors within the GitLab framework. So runners can be a very, very broad topic, but at its highest level, it's just important to understand that runners exist solely to build and run jobs for testing and execution. They're sort of the workers within the CI/CD framework. And a bit of an asterisk before we begin, during this discussion, I'll be speaking about runners specifically from a self-managed point of view. So runners are inherently flexible and they can be installed nearly anywhere. So that means you could install a runner on its own bare metal server. You could have a little VM with some space left on a host. If you had a very large need, you could have a giant standalone cluster just chock full of runners. Conversely, it could be very, very small. You could have a runner on a laptop or even a little Raspberry Pi. Runners are largely OS agnostic. They can be run on Linux or Windows or OS X. Really anything capable of running Docker could run a runner. So the only small warning I would give is that for performance reasons, runners should not reside on the same server as the instance, the actual GitLab instance. So having your runners utilize the same hardware or cloud image as the GitLab install will, sort of short term, you're thinking about performance issues and resource contention, but long term, it's going to make it much more difficult to scale and growth, right? It's obviously going to be a lot more difficult if you have to separate those items. So runners can be utilized in a ton of ways. So they're flexible, right? And they're multi-platform, and this allows a lot of tailoring to fit your requirements. This flexibility can be leveraged in the interest of minimizing inefficiencies, right? Both in cycle times but also in cost. So think about auto scaling. So runners are capable of auto scaling. So you could provision auto scaling runners via Docker machine or Kubernetes to spin up, right? So you always have the capacity to process jobs quickly, but also spin down. So you're not worried about resources being wasted or needless costs for unused VMs. You can run them in parallel. So you could have multiple runners spanning several projects. In that way, you could keep resource contention very low, right? And keep your performance high. And because you're able to utilize multiple runners at the same time, you could also ensure that runners are properly sized for the job they're sort of individually expected to execute. We could talk about that just a little bit more. Well, you know what, right now. So let's talk about runner types a little bit. So there are three fundamental types of runners. There is a specific, group, and shared. So specific runners are most useful for jobs that have very special requirements or projects with a specific demand. So let's say you're running a pipeline to verify like a large Apache Groovy application. You could envision a very robust runner with necessary Java dependencies to run those jobs within your project. And in that way, specific runners can be used to right size workloads, right? So let's say in conjunction to your very complicated Groovy application, you have an admin team that maintains a small project full of bash and networking scripts, right? They used to troubleshoot your company's infrastructure. Well, those scripts could be stored in their own project and verified via a very small and inexpensive runner, maybe on a free cloud instance or a small bare metal VM. Group runners are similar to specific runners, but surprise, just like the name implies, they're tied at the group level, right? So they can actually be used across multiple projects. When you think about both specific and group runners, it's important to know that they use a very basic sort of FIFO mentality, right? So first in, first out queue methodology. Last up, we have shared runners. Another spoiler, they're just what they sound like. So shared runners are shared across multiple projects and groups. And this is really useful for jobs that have similar requirements across teams or platforms. So rather than having very specifically chosen runners, you could have many identical ones to handle sort of the same thing over and over again. And because sometimes they can be identical, it makes it really easy to maintain and both update them when you need to. Shared runners do use a slightly different process queue that we call fair usage. And fair usage just means that it will assign jobs to a shared runner from the project that has the lowest number of jobs running, if that makes sense. And so lastly is tagged runners, and not specifically a type of runner, but tags can be applied to any runner type. So you could create a tag for Ruby or Python or Groovy, right? And assign runners to those jobs specifically. And that's a lot of granularity, right? That's a lot of ways you can sort of slice up and use runners. And what I'm really driving at here is all that flexibility ultimately results in usability, right? There is a runner which will inherently meet your business needs. So we'll talk a little bit about the executors or executors, tomato. So the executors are sort of the how of the process, as in how the runner is going to execute that script. So you'll actually choose your executor during the registration of your runner install. And there are 7 total, including a custom executor. In this, I'll talk briefly kind of about the top 3, which are Shell, Docker, and Kubernetes. So Shell is exactly what it sounds like. It runs commands just like you or I are sitting down and typing them into the terminal. There's support for several shells, so it's Bash and SH and PowerShell. And I think that the shell runner is really the easiest to install and get running. So if you're new to this sort of CI/CD process and want to get started, it's a really nice option with a lot of great documentation. So the shell runner inherits permissions from the specified GitLab runner user. So as a caveat, I would just say that because the shell inherits those permissions, it's best to only use it on machines you trust, right? I don't know if you have untrustworthy machines in your office, but if you do, like, this is not the time to use them. So shell is not the same as SSH, right? I even put it in little parentheses. So with SSH, you're potentially logging in as root to a remote server. So security can be a lot more tedious as well as less secure. In addition, SSH only supports Bash and there's no caching. So if nothing else, walk away knowing that shell does not equal SSH. So the Docker executor is just that. It's the most common, and it's an executor which runs inside a Docker image. So it can run both Linux and Windows containers. That's pretty neat. And it provides a clean image for each job, and even can be used as Docker and Docker. In this, it actually also includes Docker machine, which provides the auto scaling we're currently utilizing in our .conf instances, which creates demands for our SaaS, right? So lastly is Kubernetes. Good old Kubernetes runs as a pod inside that cluster. So the executor connects to the Kubernetes API and creates a pod, right? And in a minimum, that pod will be 3. So it'll be the build container, a helper container, an additional container for each service that you define in the YAML and TOML files. So Kubernetes can also auto-scale, of course, right? And there's some great documentation around sort of the benefits and caveats of using it versus Docker machine as an auto-scaler, and a great epic in our docs right now. So on my last page, you'll see an excerpt from our docs, straight from our wiki, that shows some of the less common executors. So options like SSH, right, not shell, VirtualBox and Parallels, as well as a high-level overview and some sort of key facts about each one of them. Lastly, I would say that, look, before you make any implementation decisions for runners or executors, please consult our docs page or your friendly neighborhood TAM for sort of the most current information. With that, I will stop sharing and I'll hand this presentation over to Brett for the anatomy of a CI job.
Awesome, thank you, Stefan. I'm gonna go ahead and share my screen. Okay. Hey everyone, so my name is Brett Gadberry. I'm a technical account manager with the commercial team at GitLab. So today I will be presenting the anatomy of a CI job. So in this presentation, I will describe a typical job sequence and some of the actions that trigger pipelines. So typically a job sequence begins with a git action, such as a push or tag push event. Jobs themselves are defined with constraints that state the conditions under which they will be executed. So for example, the rules keyword allows for a list of individual rule objects to be evaluated in order until one matches and dynamically provides attributes to a job. Once defined, jobs are enqueued in a background job processor called Sidekick. So here the job would only run when the commit branch is master. And then on the next example here, we have the job would only run if Docker file is changed. So first, runner pulls the Sidekick queue to receive jobs. Runners can be filtered, as Stefan mentioned, using tags and/or protected branches. Once a job has been received, runner downloads the specified Docker images. The image keyword is used to specify a base image, and the services keyword is used to link service images to that base image. The get strategy keyword is used to specify the method for getting recent application code in the working directory. So clone clones the repository from scratch for every job. Fetch reuses the local working copy, and then none will reuse the local working copy, but will skip all Git operations. The default Git strategy can be configured at the project level on the CI/CD settings page. So the GitLab CI YAML file, as Chester will describe, defines the structure and order of the jobs and determines what runner executes, including which decisions it makes when specific conditions are met. So the before script keyword is used to define commands that run before each job. Commands specified in before script are concatenated with commands specified in the main script, meaning they are executed together in a single shell. The after script keyword is used to define commands that run after each job. Commands specified in after script are executed in a new shell separate from the main script and before script. The script keyword is used to define the shell commands that really make a job unique. Script is required when defining a job and will always result in either pass or fail. The allow failure true keyword allows a job to fail without impacting the rest of the pipeline. So next I'll describe 5 additional actions that trigger pipelines. So first here we have is in the context of a merge request. So you may be familiar with the only and except keywords, which are other job constraints used to limit job creation, but they are soon to be deprecated and should not be used. So instead, we have the if CI merge request ID rule, which is the recommended method for only creating jobs in the context of a merge request. Past that, pipelines for merge results can be configured at the project level on the general settings page by enabling the setting, merge pipelines will try to validate the post-merge results prior to merging. So this setting becomes available in premium and silver tiers. Next, we have the manual play button. So the when manual keyword makes it possible to execute a job manually. The action will expose a play button for the job. The job will be triggered only when the play button is manually clicked. The play button is accessible in pipeline, environment, and job views. So finally, on my last slide, we'll have the trigger, webhook, and scheduled job actions. So a unique trigger token can be configured at the project level on the CI/CD settings page under pipeline triggers or the triggers API. To trigger a pipeline using a trigger token, simply send a post request to the trigger pipeline API as seen here. To trigger a pipeline from a webhook of another project, add the webhook URL to the project's integration settings page. The pipeline will then be triggered at the corresponding event. And then finally, the pipeline schedules can be used to run pipelines at specific time intervals. Pipeline schedules can be configured at the project level on the CI/CD settings schedules page or the pipeline schedules API. So that's my last slide. So thank you for your time. Next, I'll hand it over to Chester, who will be presenting the CI YAML overview and its capabilities.
Okay. Thanks, Brett. So let me go ahead and share my screen. Okay. So yes, so we've discussed. Hi everyone, my name is Chester Wachuku. I'm a technical account manager at GitLab as well. And so my colleagues have discussed runners and executor types and the anatomy of a CI job. So I'll be going over the CI YAML file and giving a brief overview of it. Okay. So once you have your GitLab project created and you want to create your first pipeline, there's a few things to keep in mind. So basically, there are some reserved keywords that you should take note of that you aren't allowed to use as the names of your jobs in your CI pipeline. And I have a list of those over there on the right side of the PowerPoint. And I'll review them. I'll go over them in the next slide as well to explain them in depth. So the next point is that there are default parameters that you can set in your CI YAML file that allow you to be able to specify some global variables and default parameters that you would like to use throughout your different stages in your job. And basically, this will allow you to not have to repeat definitions in particular stages of your pipeline and allow you to reuse certain functionalities. The next point is spaces and tabs. So there's a tendency for folks to use to alternate between spaces and tabs as they're writing code in their favorite IDE of choice. But when it comes to YAML, spaces can cause issues if you don't have the right number of separations between elements. So to avoid this, it's advised to use spaces over tabs and just to avoid any syntax issues. And the GitLab Web IDE has assistance capabilities that allow you to avoid some of these issues that come up in terms of spacing issues. The last point is once you have your CI YAML file created and you're ready to run your first pipeline, there's a CI lint tool that will allow you to validate the syntax of your YAML file. And every GitLab project has this capability. So once you go into your GitLab project UI, there's an option to select CI/CD on the left-hand side of your GitLab project. It'll produce a drop-down. You select pipeline, and you'll see this three-button option at the top right-hand corner to choose run pipeline, clear your cache, or select the CI lint tool. You select that CI lint tool, it'll take you to a window, you drop your CI YAML file in there, it'll validate it and let you know if there are any syntax errors. So you can be sure that you won't have that issue as you're running your build. Okay. So I've listed out all these parameters. My colleagues have gone over a few of them, so I just want to reiterate some of the important ones. So as mentioned, the script tag parameter allows you to supply commands that you would like executed in your shell. The image parameter allows you to specify which Docker container you'd like to use in your pipeline. The services parameter allows you to associate an additional service that's tied to your image. So for instance, if you want to use a Docker and Docker service, whereas you want to pull a container, log into a registry, or create an image while during your build process, you can use that functionality to do that. The before and after script, as my colleagues mentioned, before allows you to set a set of commands that you'd like to execute before the script parameter is invoked. So for instance, if you want to install some packages from package manager or do some brief authentication commands, you can specify that there. The after script allows you to do any cleanup work. So this parameter will allow you to basically, it'll execute despite whether the job passes or fails. So you can do cleanup work in terms of remove any sensitive credentials that are remaining in the runner. So to just make sure that you're not basically to avoid any security violations. Oh, So the stages parameter allows you to specify which different phases you would like to be executed in your pipeline. So you can specify you want development stage, build stage, test stage, and deploy stage. And the ordering in which you list these stages matters, and I'll show that in the next slide. But just keep that in mind that the order in which you list the stages matters. And the only and except, as my colleagues mentioned, they're being deprecated. But these are just conditional statements where you specify, hey, I'd like this job to run only in the event of a merge request, or I'd like this job to be run in the event of a merge to master, right? So you can specify those conditions. The rules expression allows you to do the same thing, but it just gives you more flexibility and to specify those conditional statements. And I'll also show you all a link at the end of the presentation where you can see all the definitions for all these parameters. So this is an example CI YAML file. As you can see, the stages is one of the first definitions that I have here. And there's a prep stage and there's a build stage. So the ordering matters, right? So if I listed the build stage first and then the prep, then the build stage would get executed first. So, and that's regardless of which stage I have defined here. So for instance, if I had the build stage second, but defined if I had the build stage set in the stages section as a second portion of the list, and then define the build stage here, it would still execute the build stage in this before the, sorry, it would execute the prep stage before the build stage. So just keep that in mind that the order matters. So in the prep stage, declaring a folder, I'm creating a folder in the script. I'm creating a file, and I'm using this artifacts parameter to store the contents of that folder so that I can access it in the next job, right? So if I never declared the artifacts portion, then that folder that I create will not be accessible in the next job. So just keep that in mind, that if you want artifacts to be propagated from one job to the next, you want to make sure to use functionality such as an artifacts. In the build stage, I'm simply accessing that folder, and I'm adding a file, or at least I'm adding text to that file that's within the folder, and it just goes to show you how you can complete some functionality in one stage and access it in the next stage. So in the on this slide, I'm demonstrating how you can use the environments capability. So this allows you to specify an environment that you would like associated with a job. And as you can see here, I'm using predefined environment variables. So the CI commit ref name, that's basically referencing the commit that's tied to this particular job, right? And so basically, this also highlights one of our capabilities with Auto DevOps that allows you to create these ephemeral environments. So you can spin up an environment to test out a feature, a code commit that you recently submitted, and you can test to see and make sure that that feature is behaving as expected in that environment, where you'll be able to access and see how it works. So this is another CI YAML file, an example one of a Ruby pipeline. As you can see, I'm referencing Ruby specific language here. So using the bundle capability and the rake test as well. So just an example of how you can use the GitLab CI YAML file for different types of tech stacks. And as you can see in the stage and deploy stages, it's an example of the code being deployed to Heroku. So it's an example of the continuous deployment capability as well. As you can see that code is being deployed to Heroku. In this pipeline, this is an example of a Java pipeline. So it's just 2 stages, and here's an example of the before script being used, and it's basically changing the permissions on the file to allow it to be executable. And basically, as you can see, I'm using the artifacts parameter as well to store the jar from the output of that executed file. And in this case, it's being deployed to a pivotal instance. And as you can see, there's a condition that this job will only run when the code is merged to master. So I want to show a section in our docs that will give you a language reference for the CI YAML file, where you can access, more information about other capabilities that you can take advantage of. And the section just goes into depth about those parameters I mentioned, and you can learn more about each one. And there's many other areas of this doc that can be helpful in you understanding how different capabilities of the YAML file works. And there's also a section on CI/CD examples, where you can see different use cases of how to deploy GitLab pages, or how to set up a game development pipeline using our GitLab CI YAML file. And so there's just a wealth of information that you can access and not have to start from scratch. And you can use these examples to basically get up and running pretty quickly. So that concludes my portion, and I'll pass it over to Patrick Harlan, who will wrap up this session.
Thanks, Chester. Yeah, if you can just stop sharing, I'll share mine. All right. Well, that concludes our webinar today. Thank you to everyone for your participation and attendance. We'll be sending a recording out to all attendees, as well as anyone who was not able to attend today. So look for that later on today, Pacific time. Just a quick rundown of some of the things that will help you get started quickly. I think Chester touched on some of these, but there's, if you just search for GitLab runner install, that'll take you to our documentation for choosing a runner, getting it installed and registered to your GitLab instance. It's very easy to install a runner on your laptop or anywhere else that you'd like to get started. Your GitLab admins may also have shared runners available. This CI YAML reference that Chester showed is here in the link here in the deck. It's a great resource for learning about the different capabilities and then the examples as well. And really, if you just search for GitLab CI reference, that's going to give you generally this document, and it has links to all these other documents for getting started as well. For those folks that have questions and want to understand next steps or some of the ins and outs of the topics we covered today, we don't have the ability to take questions live right now, but contact your technical account manager. Your GitLab administrators should know who that is and can reach out. And if you're not sure, just feel free to contact me. I'm Patrick at GitLab. And depending on the number of questions and responses, I'll get back to you as fast as I possibly can. So thank you, everybody, for participating today. Thanks for your attendance. Have a great rest of your week, and we hope to see you again soon.